try. All right, it's live. Shh. Silence. Okay, third hour. Is it moving? Or are we frozen? Oh, we're frozen up there. So far, so good. My computer restart occurred, and it was okay. Oops. Oh, that's right. I have to reconnect. Sorry. Let's pause the video for a second. Good start. Okay, here we go. 20 seconds wasted already. All right. So because of our computer malfunctions and whatever, we have this written down. We can proceed on. All right. Here comes my little diatribe. Anyone know what a diatribe is? Negative rant that I have every single day here, right? I did always do 1-7, but I did it kind of light. And there are a couple questions on my exam, and I only had it in a multiple choice. Because we're in these communistic times. Yeah, I put it in the video because I don't care. All right? I was forced beyond my feelings about what I think should happen to make a common assessment with the other CAT teachers. And to do that is a process. The more teachers involved, the more difficult it is. And everyone knows that in this department. So I'm not saying anything bad about anybody, but it comes down to what questions do what teacher like, and how do we get to a consensus about what gets on the exam. And I'm just going to be brutally honest that I gave in, and some of the teachers liked 1-7 a little bit more than me. So there are more 1-7 questions that I would like to have on the common assessment. I feel like it kind of just comes out of nowhere with these word problems, but it is the function chapter, so all of these are about functions and word problems with them. So on the common assessment that I was forced to go along with everyone else, we have probably about 5 or 6 1.7 questions. Word problems that you need to either translate into an expression or actually solve. So I'm going to spend 2 days or so on this. We had to, clean up our quizzes from the sub mistake. So we're a little short on time in that anyway. But usually I kind of left it light. Tomorrow I'll show you some of the more complicated ones that they do and give you that warning. All right? So I'm sorry. I'm going to be brutally honest. And the screen just flickered. So we'll see if we're going to be okay here. Maybe I'm going to flip this and then see what happens there. Probably all heck's going to break loose when that occurs. Nope. Let's see. All right, so it righted itself. All right, so let's proceed on, and I'll tell you that there are many geometry questions. I'm holding up my book in class. When you have a geometry question, you might have to remember some formulas. So in my class, I'm holding up the book that this does not exist on the online book. You'd have to go to the hardcover book. And many college textbooks, which I believe this is kind of a college textbook, has a lot of formulas on the cover. Do you see that? Really, it's on the front cover, page 2 of the front cover, where you got your common geometry formulas. So I'm showing that to class right now that those exist. If you get a geometry question that you don't know the formula, you better remind yourself by doing that. There's some other formulas on the back cover, but I don't think there are any geometry ones. Yeah, that looks like some trig ones. So it's that front cover that you want to look at. But I want to throw this book at you if you don't know. Did he just threaten the students? That if you don't know the formula for area of a circle, because my daughters know what that is. What's the area of a circle? Pi. Delicious. Pi what? R squared. Not 2 pi r. What's 2 pi r? I got to get my draw. 2 pi r is what? No. 2 pi r is not diameter. Circumference. And people often screw those two up because they both have a 2, a pi, and an r in it. All right? So I will be honest that this first question is super simple, but I inverted it in my mind in previous years, and I'll show you some of my old work. Write the area of a circle as a function of its radius. And that is the answer. The answer is A equals pi r squared. The area is a function of the radius. That means the radius is the input value, and the area is a function of the radius, so it's the output value. I will share this. Let's call this part B. But what I did is I did it in reverse. I showed my mistake of the past to second hour. Let's put this part A2. Write the radius as a function. Sorry for this chicken scratch, but I'm squeezing this of the area. Sorry, that was me, my brain stopping, not the computer. And that's a reversal of the situation. That's saying A is the input and R is the output. And you do this all the time in physics. All it is rewriting a formula in terms of another letter. We've already done literal equations, right? And the answer would be this, solving for R, that little equation that we have up there. So the first one is the answer for A. Radius, area is a function of the radius. That is true. This is the radius as a function of the area. And I just I thought I'd share that so that you understand what it means for something to be a function of something else. All right. So basically what you have to do is solve for R. Notice that plus minus. Why do I really burn? Remember burn? Okay, when you square root both sides, you put plus minus in front. Why did I cross it off, though? Why do you think I cross off the minus part after that? Because a radius cannot be what? Negative. This is a real-world geometry question. So a lot of times those negatives drop off, you know. They don't count. So do be aware of that. All right, now we're back to the traditional write the area as a function of the diameter. And really, this A2 doesn't apply to that. So this doesn't apply to the rest of the question. I was just sharing something with you, sharing an idea of what it means to be one thing a function of another. All right, and that second one is definitely a reversal of the first one. Okay, so this right here, if you were half listening, is radius as a function of the area, not area as a function. Do you have the written part? Let me have that too, or whatever you had for work. Okay, now, what's a diameter? What's a diameter? I already heard someone say it. I'm going to write in yellow here. 2 R's. So the diameter equals 2 R's. All right, so but what I need to do is I need to take this A equals pi r squared, and I need to replace, and I want to go back to, you won't see that yellow. So again, I told you that this doesn't apply to what I'm doing in the next part. All right, so I am going to get rid of that for right now. And I'm back up to here. Let me get my highlighter. I'm back up to using this equation and rewriting it in terms of another letter. Okay, so I want to do a replacement. And I know a diameter is 2 radii. What do I have to do with that equation so I can replace R? What do I have to do? Someone said it. Say it louder. Solve for R. What is R equal to in terms of the diameter? D divided by 2. That's very simple. A radius is half of a diameter. Then what I can do is go up to this equation and replace that R with the D over 2. And then that is all squared. Okay? Now, for purposes of understanding, you better get this. This is pi over 1. So to rewrite this, this would be pi up at the top times d squared over 4. The pi goes up with the d squared. If you still don't get that, you're driving me nuts. When you multiply fractions, you multiply the numerators and multiply the diameters. Pi is pi over 1. So pi gets multiplied by the d squared. We keep practicing this over and over again because at some point it's going to come and get you if you don't know how to do these basic grade school fraction ideas. So that's why I do that. And then, what did we just say circumference is? What's circumference? 2 pi r. Or, what's 2 r's? What is 2 r's? See, because we want to build off of the last one we just did. We want to build off that area as a function of the diameter. So area equals pi times d squared all divided by 4. And then what I want to do is do a replacement in that one. Or I could go and keep 2 pi r one and then replace in the original, if you get what I'm saying. I could take this r up here and replace it with what I find c is in relation to that. But I'm going to stick with that. So if I want to replace with d, I got to solve for d. What is d? Solving for d. Okay, I wrote it. It's taken forever to write up on the screen, which means we got some internet little action going on here. Come on. Come on. You don't see this online. Did you see that, class, how long that took to write? That means we got some issues. All right, so what's d equal? How do I solve for d, this equation? C over pi. Then what I can do is, on the previous question, I can replace d with c over pi. Again, we have this stall in the classroom. I don't know what's going on with the wireless, but all the teachers are complaining about these wireless issues. So I'm going to complain every time until it comes up when it's written. So I'm going to stop complaining. All right, so A equals, it's still not written yet, so we get to complain again. Pi times D. Again, I sound like a moron online because you don't see what's happening on my screen in class. And I replace D with C over pi. And now I have area as a function of the circumference. So it's a building thing. I didn't complain because it actually wrote that time. Divided by 4. Oh, you better hurry up or I'm going to complain. There it is. Okay, now what you have to do is go ahead and simplify. Maybe I could fit that here. Pi times c squared over pi squared. You square both. I'll zoom in on this. Divided by 4. What happens with one of the pi's? Hurry up. It's not writing in class. It's not writing in class. It's still waiting to be shown on the board. Stunning for YouTube. All right. And then what happens with one of the pi's? Again, knowing your fractions. Even though I have a fraction within a fraction, we should be able to handle this. They cancel. And then where does that last pi belong? All right, when I cancel that one with one of the pi squareds. The squared's going to cancel out. I'll cross it off again. And the answer to that is A equals c squared over 4 pi. That leftover pi, c squared over pi over 4, does end up being c squared over 4 pi. Very simple way to explain that. I guess I should, even though I shouldn't be teaching basic fraction work. C squared over pi over 4. This over is division. This means c squared divided by pi divided by 4, which is the same thing as c squared divided by pi times the reciprocal, right? See how all that happened? Therefore, the pi ends up with the 4, knowing that in a fast way. Okay, I'll press pause for a second to take a breath. Okay, here we go. All right, and then moving along with the geometry idea. Not just throw out there that on the test, we got about 4, 5, 6 of these questions, and a few of them are geometric and, knowing geometric formulas kind of thing. So here's the next one. The area of a triangle, so it says up at the top, write a mathematical expression for the quantity described verbally. So we got quite a few of those. Not quite a few, but a few of those. And this one says the area of a triangle whose altitude is 2 more than its length. And I should have asked you this. I should have blanked this out. But for purposes of what you're supposed to know, knowledge coming in, altitude is the same thing as height. Right? We know that? We should. Basic vocab. All right. Let's put my book over here. All right. What does 2 more than mean? Plus 2 or 2 times? Which one is it? Plus 2. So when I look at this, I wish I could keep this. That's actually a little bit bigger. The base is x, and you got to really kind of draw this to get a feel for it. The altitude to this considered base, that means the base is x, and therefore the altitude needs to be 2 more than that, which is x plus 2. And then here we go. I would say 2 of my 3 daughters know this formula. What's the area of a triangle? 1/2 base times height. You'd make me infinitely sad not knowing that. And then what you do is a simple replacement on this one. Simple, simple, simple. The base is x, the height is therefore x plus 2, and that would be an acceptable answer. One thing I could say is, say this was multiple choice. I do need I'll just go purple, I see it available. Hey, and this is purple already. I could distribute this half, then this and this x, and it could be listed as half x squared plus x, right? Because what's half of 2? What's half of 2? 1. And then x times that 1. And that's how I end up getting that. So again, it could be a distributed answer as a multiple choice, and you need to be able to handle that. Okay, so I distributed the x and also distributed the half to get those two parts of that expression. Now, I am not going to do the next one yet. I'm going to go to one last geometry one. And we'll take a look at that one. And it is number 15 out of your book, which I don't mind doing. Okay, so zooming in on this and holding it. The height of a right circular cylinder. I think they're called regular prisms, right? When they're right, right angles at the corners, and that's only what you dealt with back in your little geometry sections of Math 2 or 3. So right circular cylinder is like a pop can, which I've drawn here. So draw a circle above and below, and then connect them. NH, you okay over there? You're drifting. You're staring at the tiles on the floor. A little nervous for you. You just made the video. Nice. You know who you are. Sorry. Write a volume of the cylinder as a function of the radius. So we need this in terms of r when we're done. Whoops. That's the wrong thing. Thought that was my highlighter. And it's fine that we're stalling. People are writing. Some people are writing some notes. Some were staring at the floor, but that's all right. Now, what's a diameter? We just said what a diameter is. Compared to the radius, a diameter is what? Anyone? 2 radii. So for us to get this in terms of a radius right off the bat, we just got to do a simple thing. So the diameter of the circles up and above and below are also 2 radii, and that's what we're going to do, and that's what we're going to use as our situation. And then my drawing is way far from scale, but I just wanted to draw a cylinder kind of large. Obviously, what in the world just happened there? Okay, all right, we're okay. We're okay. Obviously, this length is not the same as this length when I look at it. But I just wanted a cylinder to look real good. That's what they're stating, though. They're stating that the height is equal to the diameter's length. So, therefore, the heights I will label the same way. And that's what you need to do so you get these all in common variables. And that's all fine and great unless you don't know what the area of a cylinder is. Wrong. Volume of a cylinder. Do you remember this? Big B times H was a standard. Hey! We have another sleeper in here. Wow. Weird. Same group, too. Are you going to be next? Good. Uh-huh. Anyway, how you doing? Good gum, huh? All right. So, big B times H. What does that big B stand for? The base is what? The base is, starts with an A, area times the height of the prism. And that works for a cylinder. It works for a rectangular right prism, regular. It works for any prism, no matter what the base is. So that's what this formula is. What is the base? It's a picture of a what? Circle, and the circle's area is what? What's a circle's area? We just said it before. Pi r squared. So, oh, that's the answer. What I have to fill in is this. Well, the area of the base is pi r squared times whatever the height is. Well, the height is 2r as stated in this question of I have a height that is equal to the diameter's length. Someone looking at their nails over there? Great. All right, and then when we simplify this, it should be simple. R squared times r is 2r cubed, or r cubed. So we have 2 pi r cubed. All right, that's in the specific scenario that they say I have a cylinder whose diameter is equal to the height of that situation. And then you draw it. Okay, taking a break. Okay, by the way, poor second, you son of a gun. It just did it again. I love this computer. I love you. I love you as much as I love Common Core. All right, here we go. Hero, it's called Heron's, I think, formula. I'm just giving you a hint that number 17, we do have this later, but it's in the trigonometry chapter. They throw this formula at you. Shh, silence. Okay. For number 17, they give you a triangle where they just give you all 3 sides. They don't tell you if it's a right triangle. In fact, you could find out if it was or wasn't. So you're going to be needing Heron's formula, where S, that's an S. I know my S's and 5s, many S's and 5s people write look the same. S is called semi-perimeter. What's semi mean, by the way? What's semi? Partial, but really it does mean half. Okay? So semi-perimeter, you find the perimeter of the triangle and divide it by 2. Get that number, and then that number gets stuck in the Heron's formula for area of a triangle as well. It's when you're given all 3 sides of a triangle. This is the only, not the only way, but it's a fast way. So given 3 sides of a triangle, you can find the area of that triangle just by inserting these numbers. But first, you got to get the semi-perimeter, and then that semi-perimeter exists in 4 different spots in the formula. Not going to derive the formula, and I think maybe you've seen it, but it is an obscure formula. It may or may not even be in the front cover of your book, and I forgot to tell second hour that, so I'm going to see. Nope, I don't see it. Okay. Then we have these random expressions for just word problems in general. And I'm going to build off of this tomorrow going into this. And then some other specific types of word problems that the other math teachers, all kidding aside, liked that threw in there. I just feel like it's a little over too many different things in this chapter that putting those in there. But we're stuck with it. So I lose money. So I have income after a 3% drop in the current income of X dollars. Okay, and you have to understand this as we write this down. I make X dollars, and I'm going to lose 3%. This is how it's written as an expression. I'm just going to share it with you in our shortened time. Right? I have X dollars, and that's what I make, but then I lose 3%. First of all, know how to work with a percent. You move the decimal twice, so it's a 0.03 times X loss. I think everyone would know if I made $100,000 and I lose 3%, I would now make $97,000. Because 3% is only $3 loss, or in this case, 3,000, the way I express that. So minus 0.03 times X, no matter what that is. And basically what I'm making is 0.97X of what I used to make. If I had an increase, then it'd be a plus, whatever the percent increase is. All right? And then knowing how to work with this, and I have another question I shared with the other hour that people mess up. These are just expressions. The actual cost of an item selling for X dollars if the sales tax rate is 8.75, which is roughly kind of close to what it is in some areas. All right, so you have a sale price on a thing that is X, and then you know it's not going to be what it costs you. You're going to pay more for the taxes. So the expression for that one is X dollars for the cost of the shirt listed on the, whatever, the price tag, and then you have to add 8.75% of that price for the taxes. So that's actually what you're going to pay for that shirt. All right, you can go ahead and put your stuff away, I guess, but I'm going to keep yammering. We do have one of these again, and I do put one of these on the test, so hopefully you can remember that box question where I have a piece of cardboard, and for some reason, you've done these before, right? You cut the corners out of there, and then you can flip up the sides, and you have an open top box. You ever done this before? All right, this is what mathematicians love these for some reason. So you got to imagine you cut these corners out of this box here, and the question said this was an 8 by 15 piece of cardboard. So if I cut X out of these corners, you have to understand 8's been reduced by X on this side and that side. So this new length from here to here is 8 minus 2x. And this 15 has been reduced by 2x, x on each side. So this new dimension is 15 minus 2x. What happens when I flip up this flap? How tall is this flap? Well, it's this tall, which is x. Oh, sorry. Wanted to highlight that real quick. So it is that tall. So the volume expression, volume of a box, by the way, is length times width times height, is 8 minus 2x times 15 minus 2x times x. So we love these questions, mathematicians. And then you can go ahead and go on a graphing calculator and type that volume in Y1 and then find this maximum. And that should be successful. We've actually done this before in this class. It's not the first time we've had that problem of that type. So hopefully you do okay with that. We'll talk more about 1.7 tomorrow.